All right, let's pick up where we left off. Here it says, give a possible factorization of the following polynomials. Do not multiply out the factors. Be sure to use your knowledge of leading coefficients and repeated zeros. Okay, so the first thing I would do is identify your zeros and their multiplicity. So I have one here, it crosses the x-axis here and here. So that one would be -3. So at x equals -3, it has a multiplicity of what if it crosses right over? Make this a little bigger. Okay, remember if it makes a straight cross, its multiplicity is 1. Okay, the second one is at 0. Again, it crosses straight over, so its multiplicity is 1. And the last one is 2, and it also crosses over. So all of these have a multiplicity of 1. Okay, that helps me know what exponent to put on the factors. Okay, I also need to look at the end behavior. It's going down to the left and up to the right. Okay, that tells me that it's going to be an odd degree. Okay, and since it's going down to the left and up to the right, it's following y equals x cubed. And so the leading coefficient is positive when it goes that way. Okay, so I know it's positive out front. Anytime you have a 0, I would put that one first because that's just an x without, it's not in a parentheses or anything. So it's best to put that in the front. So I have positive x since my leading coefficient's positive. And then my next one at -3, okay, it's to the first power. So that would be x plus 3. And then at 2, that would be x minus 2. Its multiplicity is 1, so it's to the first power. So it's x times x plus 3 times x minus 2. That would be a pretty decent equation for that. There could be some stretches that we're not taking into account, some vertical stretches and shrinks, but other than that, we have the equation of that graph. Okay, look at number 2. Okay, so this is my x-axis here. So it crosses here, and here, and here. And I've got some interesting things going on here. Okay, this has a multiplicity of 2 because it bounces. Okay, this one is just multiplicity 1 because it goes straight across. But do you see the twist here? So that one has multiplicity of at least 3. It's an odd that's not a 1. So let's just do 3. Okay, so that's at -2. Has multiplicity of 2. At 1, it has multiplicity of 1 as it crosses straight over. And at x equals, is that 4? Has a multiplicity of at least 3. It has to be an odd number greater than 1. Okay, check out the end behavior. They're both going down. So that's like your parabola going down like this, which means it's reflecting across the x-axis, so it's going to have a negative in the front. I'm not going to worry about vertical stretches and shrinks on this. We're just going to put in the negative and then put in our zeros with the correct exponent. So for -2, that would be x plus 2. Its multiplicity is 2, so you put a square on it. The next one is x minus 1, and its multiplicity is 1, so I'm just going to leave it off. And then at 4, that would be x minus 4, and its multiplicity is 3. So minus the stretches and shrinks, there's a basic equation for that graph, the factorization of the polynomials. Okay, look at number 3. Okay, we have this 0 and -1. It bounces, so it's multiplicity 2 because it bounces. Okay, then it crosses again here and bounces. So again, I'm going to say multiplicity of 2. And here it crosses, so it's multiplicity of 1. So the second one was 2 with multiplicity of 2. The third one was 4 with multiplicity of 1. Okay, let's look at our end behavior. It's going up to the left and down to the right. Okay, so that means it's odd, so it follows the pattern of your y equals x cubed, but this time it's flipped over, so it has a negative out front, which caused the reflection across the x-axis. Remember, y equals x cubed does this when it doesn't have the negative out front. Okay, it's flipped over the other way. Okay, let's write our possible factorization of this polynomial. I know it needs a negative out front. It has a 0 of -1, so that would be x plus 1 with multiplicity 2, so I'll put a square on there. And then your second 0 is a 2, so it'd be x minus 2, multiplicity of 2, so put a square. And then the last one would be x minus 4. This is in my way now. And it'd be to the first power because its multiplicity is 1. Okay, look at number 4. Okay, here, my zeros are here, here, and here. This one we know is multiplicity of 1. This one has a twist, so it's at least a 3. And this one bounces, so it's a 2. Okay, so my zeros are -2 with multiplicity 1, 0 with multiplicity of 3, and 3 with multiplicity of 2. Okay, the end behavior is both going up. That means it's an even degree, and it follows the design of a parabola. Okay, so that means it's going to have a positive out front. So I'm not going to stick a negative there. Okay, so I have x minus -2 would be x plus 2. Its multiplicity is 1, so I'll leave that off. The second one was a 0. That means I should have stuck it in the front because it's x, and it has a cube on it because its multiplicity is 3. And then the third one is a 3, so it's x minus 3 with multiplicity 2. Okay, and the last one of these, let's look at this one. This one has a little trick to it we haven't seen yet, and it's because it's hitting at fractions. So this fraction, your 0 is at -1.5. I'm sorry, it's not right. I changed it. -2.5. Okay, which would be -2.5 would be -5/2. And so I'm going to show you how you turn that into a factor. We know on both of these the multiplicity is 1. Okay, but what you can do is set that equal to x, -5/2 equals x, and then solve and get it set equal to 0 to turn it into a factor. So I'd multiply both sides by 2. So that would be -5 equals 2x. And then just bring the 5 over by adding. So when you move it to the other side is 2x plus 5. And that's going to be your factored form in your problem for -5/2. Okay, this one on the right is 3.5. So that's 7/2. So again, you're going to do 7 over 2 equals x, and get everything on one side. So I'm going to multiply by 2, and then just subtract the 7 over. And that's what they need to look like when you put them in to your factorization. Okay, let's go ahead and write them here. So this one would be 2x plus 5. The multiplicity was 1. I kind of already wrote it over there. Multiplicity 1. Multiplicity 1. This one will end up being 2x minus 7. Okay, look at the end behavior. It's up, up, so that's positive leading coefficient. So I don't need a negative out front. So this one is just going to be 2x plus 5 and 2x minus 7. And I don't know if y'all remember from the beginning of the year when we did wrote these in different forms of quadratic. This was intercept form. Okay, let's look at this next one. We want to find the zeros of each polynomial by factoring and give the multiplicity of each. No calculator. So we'll set the equation equal to 0. We'll either factor by the greatest common factor for 2 terms, guess and check for 3 terms, or by grouping for 4 terms, and use the quadratic formula if necessary, if none of those work there. Okay, so here we have, let's factor out, there's a common factor of x. So I'm going to set this as x times x squared minus x minus 2. Okay, I'm going to set it equal to 0 basically to get a 0. Okay, then that factors into x times x minus 2 times x plus 1. If you're still having trouble factoring, you need to come in and get some extra help. I'd be glad to help you. Okay, now I can list my zeros and their multiplicity. Okay, this one gives me a 0 with multiplicity 1. This one gives me a 2 with multiplicity 1. This one gives me a negative 1 with multiplicity 1. Okay, let's do the next one. Set it equal to 0 and factor. These have an x cubed in common, so pull out x cubed. That leaves me with an x squared for this one and just a minus 4 for the second one. Okay, this can be factored more. That's a difference of perfect squares, so that would be x plus 2 times x minus 2. Okay, so now I can get my zeros. When there's an x out front, my 0 is 0. And this one has a multiplicity of 3. Okay, this one would be negative 2 with multiplicity of 1. And I forgot the parentheses. This one would be 2 with multiplicity of 1 as well. Okay, let's try a few more. This one set equal to 0. We have factor out an x, that'd be x squared plus 2x minus 5. Okay, you would try to factor this one. Your only choice is 5 and 1, and there's no way to get a 2 out of that. Okay, so I can get my 0 from the x. One of my zeros, let me list it here, is 0 with multiplicity 1. Okay, but I can only solve this one with the quadratic formula. Okay, so remember x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So I need to use that, not forgetting this, but it's not going to be part of my quadratic formula. So my a is the 1, my b is the 2, and my c is negative 5. So it's being negative 2 plus or minus the square root of 2 squared minus 4 times a times c, which is 1 and negative 5, all over 2 times a, which is 1. So again, we're ignoring that x up that we factored out front. Okay, let's simplify. That's going to be negative 2 plus or minus the square root of 4 plus 20 over 2, which is negative 2 plus or minus square root of 24 over 2. 24 is 4 times 6, so you can take the square root of 4, which is 2. Man, 2 is becoming popular here. So if you look, I could divide everything by 2, and that's going to become negative 1 plus or minus square root of 6. Okay? And so those are individual, actually. So those are 2 zeros. One is negative 1 plus the square root of 6, and it has multiplicity 1. The other one's negative 1 minus square root of 6, and it also has multiplicity of 1. Okay, the next one, if we set it equal to 0, we're going to have to do this one by grouping. So that would be x squared times x plus 4 minus 3 times x plus 4. Okay, we can factor out the x plus 4, so that's x plus 4. Oops. Times what's that factors out, so you're left with x squared minus 3. Okay, now set those equal to 0 and solve for x. So I have x equals negative 4 for this one. This one I get x squared equals 3. And when you take the square root of both sides, you're going to get x equals plus or minus the square root of 3. Okay, so I have each of those with multiplicity 1. So my zeros are negative 4, multiplicity of 1, plus or just square root of 3, multiplicity of 1, and negative square root of 3, multiplicity of 1. Okay, let's do 2 more of these and then I'm going to do one more thing for honors. Okay, on number 5, we're going to factor that first after we set it equal to 0. I have an x to the 4th, an x squared, and a constant. So I can factor like I do an x squared, x, and constant. Okay, so this is going to be x squared times x squared. That takes care of my x to the 4th and getting all these x squareds I need. Okay, your factors of 60, I need them both to be negative to get a positive 60 when I'm multiplying, a negative when I add the outer and the inner. Okay, so that's going to be 15 times 4 would give me 19. Okay, I can factor x squared minus 4. This is going to be x squared minus 15 times x plus 2 times x minus 2. Okay, so I can set this equal to 0 and solve. Let me change color for a minute. So that would be x squared minus 15 equals 0. So x squared equals 15. Take the square root of both sides, plus or minus square root of 15. Okay, so on this one, my zeros are negative 2. That's from this one, with multiplicity 1. Add positive 2 from this one with multiplicity of 1. And then at square root of 15 with multiplicity 1. And negative square root of 15 with multiplicity of 1. Okay, one last one of these, and then we're going to look at inequalities for honors. Okay, so on this one, set it equal to 0. I can factor out an x. That leaves us with x to the 4th minus 9x squared plus 20. Okay, now I can factor that into, that would be x squared minus 5, 5 and 4, and x squared minus 4. Okay, and that lets me factor this one some more. So I have x times x squared minus 5 times x plus 2 times x minus 2. Okay, I'm going to have to set this one equal to 0 again to see what we come up with there. So I have x squared minus 5 equals 0. So x squared equals 5. Take the square root, which gives me a positive and negative. And there's my roots from the x squared minus 5. Okay, my other zeros, though, I have one from the x, so that would be at 0 with multiplicity 1. Okay, the next one was the plus or minus 5, so I'm going to have square root of 5, multiplicity of 1, and negative square root of 5, multiplicity of 1. Then from the x plus 2, I'm going to get negative 2. And for the x minus 2, I'm going to get positive 2. And these both have multiplicity of 1. Okay, well, let's look at the inequalities and how those work now. All right, we're still going to use our zeros even on an inequality, but we're just going to use a number line. I just care whether it's above the x-axis or below. So this is your x-axis, and let's figure out what's going on here. This one's already in factored form. I need the values that are below 0 when I get this graphed. Okay, so I know the degree is, well, let's list our zeros and multiplicity, and that makes it easier to get the degree. Okay, I have 0 with multiplicity 2. I have 2 with multiplicity 3. And I have -3 with multiplicity 1. So if you add up the multiplicities, that gives you your degree, which is 6 in this case. The leading coefficient's +1. And my ending behavior, since it's positive and it's even, is going to be up. Okay, so let's put in order from least to greatest. Let's put on our number line our zeros. So I have -3, 0, and 2. Okay, I know it's going to bounce at 0. It's going to do a twist. This is a bounce because of the multiplicity of 2. This one's going to have a twist at 2 because of the 3 multiplicity. And this one at -3 is just going to cross right over. So it's going to do something like this. It's going to, let me change colors. It's going to cross at -3. Remember, it's going up to the left, so it's coming down like this. And then it's going to bounce at 0 because the multiplicity is 2 there. Come down, and then it's going to, because the multiplicity is 3, it's going to do a little twist right there, and then go back up. Okay, I want all, now this is kind of like what we were doing before now in Unit 6 with our inequalities. Okay, I want to find all the points on the graph of this curve that fall below y = 0. So that's going to be below this x-axis, and it can be equal to. So let's see if I can find a highlighter that would work. I'm going to do less than or equal to would be below it, and it would include the points that they intersect. Okay, and it's okay to go up and touch and come back down like that as long as it didn't cross over. Okay, so that's the part, and I'm going to write it in interval notation. So in this case, this one is going to go from -3 and can equal 3 all the way over to 2. Even though it touches 0 here, I can still keep it going as one big inequality. So this would be from -3 to 2. Okay, look at the next one. Okay, let's list the zeros. I have one at 4 with multiplicity 1, so it's going to cross right over. This one's at 1 with multiplicity of 1. And this one's at -3 with I don't know, I did parentheses there. -3 with multiplicity of 3. Okay, let's see if we can graph a sketch of this. And you want to go from least to greatest. So I'm going to go -3 first, and then 1, and then 4. Okay, let's look at our degree, which is 1 + 1 + 3, which would be 5. Okay, and the leading coefficient is positive. So that means when it's odd and positive, it's going to go like the y³, and it's going to go up to the right and down to the left. Okay, so at -3, I know that there's a twist because of the 3 here. It crosses over at 1 and it crosses over at 4. Okay, let's give it a try. So it's going, did I talk about end behavior yet? No, it's positive and it's odd, so it's going to go down to the left and up to the right. Okay, so that means this is coming up, and it does a twist at 3, and then it comes up and goes back down at 1. And then it comes down and crosses again at 4 with those multiplicities of 1. Okay, I want all the values of that graph that are greater than 0. So that's going to be anything above the x-axis, which would be all of this here. Okay, if it's broken up like this one is with a gap between it, you'll have to use your little u to bind them together. Okay, so I know it's above from -3 to 1. It can't be equal to 0 this time, so I do a parentheses. Oh, let me change my pen back. So that would be -3 to 1. Then it picks back up and goes from 4 to infinity. Okay, 2 more. Oh, this one said, what if we wanted it less than 0? Then the only difference is it would have a parentheses instead of a bracket. Actually, that's not all. There's one more thing that would happen. This includes the 0. I need to exclude it. So technically, I would have to do this. I would have to go from -3 and stop it at 0, and then pick it back up and go from 0 to 2. Okay, that's what would be expected there. Okay, let's look at the next one. So this one, I need to factor first, and those things are in my way, but that's okay, we'll make it work. Okay, so my degree, well, actually this one you can tell the degree real easily. Just look at each term and keep the highest one. My degree is 3. The leading coefficient, you would actually want to rewrite this one in order from least to, in descending order. So I would do -x cubed minus 5x squared plus 4x plus 20. Okay, so my leading coefficient is actually negative. It's -1. Okay, and it's an odd power. So since it's negative, it does a reflection across the x-axis, so it's going to go this way, where it's up to the left and down to the right. Okay, so if we make a sketch of that here in a minute, I'm going to have to first factor that. Okay, so let's group those two together and these two together. Yikes. Okay, my GCF of 4x plus 20 is going to be 4 times x plus 5. My GCF of the next ones will be -x squared, which will be 5 plus x, which is the same thing as x plus 5, so you can factor this out. So that'd be x plus 5 times 4 minus x squared. Factor that as a difference of squares, and that would be 2 plus x and 2 minus x, less than 0. I guess I really should write that instead of the equals up front. Let me get rid of those. Okay, if I graph those, they all have multiplicity of 1, so they're just crossing right over. So my zeros are going to be -5, multiplicity of 1. This one gives me -2 with multiplicity of 1. This one gives me +2 with multiplicity of 1. So they're all going to cross over. So I'll start at -5. Go to -2, and then go to 2. So remember, it's up to the left and down to the right. So I'm going to come from up to the left and go down, cross, cross, come back down and cross. Okay, now I want the part of that graph that's below the y equals 0, which is at the x-axis here. So the part I would want is this part right here. You can see that. Change color. Okay, and then this part too. And because it doesn't have the equal to, I have to exclude, do open circles on those points right there, including the -2. Okay, so my answer is going to be, yikes. Okay, it's going to go from -5 to -2. That's the part below that axis. Then it picks back up and then drops after the 2. So from 2 to infinity. Okay, last one. Here, my degree is 3. It's already in descending order. The leading coefficient is +9, so it's positive. So since it's odd, it's going to follow the behavior of y equals x cubed. So it's down to the left and up to the right. Okay, let's factor that. These have a greatest common factor of x. So it'd be 9x squared plus 12x plus 4. Greater than or equal to 0. Now I need to factor that. Looks like a perfect square trinomial. That's going to be 3x plus 2 times 3x plus 2. So I'm going to write them with an exponent to get my multiplicity. Okay, so my zeros are going to be 0 with multiplicity 1. This one, if you need to, you can come over here, set it equal to 0 and solve for x. So it's going to be -2/3. Some of y'all are getting where you can even do those in your head. Okay, so I have -2/3, and this one has multiplicity of 2, so it's going to bounce there. Okay, so let's put those two zeros on your graph, or at -2/3, and then at 0. And it goes down to the left and up to the right. So I'm going to come up here. It's going to bounce at -2/3 since the multiplicity is 2. Then it goes up like this.